So now in part B, we want to use the second derivative to determine if our answer in part A is an underestimate or an overestimate. So the first thing I need to do is take my first derivative and differentiate it again. Now notice that the denominator of my derivative is t, so I'm taking the derivative with respect to time. So dw, d squared w dt squared is 1 over 25 multiplied by 1 dw dt. So d squared w dt squared is equal to 1 over 25 multiplied by the first derivative again. So my second derivative is going to tell me my concavity at the point of tangency, and we want to see if our function was concave up or concave down. So I'm going to take this second derivative and plug in our point of tangency to see if we get a positive or negative number. And that's going to give us 1 over 625 multiplied by 1400 minus 300. So that is 1100 over 625, which is greater than 0. So remember, if your second derivative is positive, then that means that your function is concave up. And that means that any estimate that you use from your tangent line is going to fall below your original curve. So let's summarize that in our answer. So we can say our estimate in part A is an underestimate because our second derivative evaluated at our point of tangency is positive, which means that W of t is concave up, therefore greater than our linear approximation. So you might be able to summarize that in your own words, but that's a complete explanation of why our linear approximation is an underestimate.